All right, guys, let's look at today's essential question. Your essential question is, how do we define extrema of a function? And obviously you can tell I cannot spell. It's an A, extrema. And your vocabulary words are extreme values, not extreme sports, max and min, critical numbers, and that is, no pun intended, critical, relative versus absolute, and we're actually going to cover the EVT, not ET, extreme value theorem tomorrow. All right, let's just go over some notes. Extrema of a function. Basically, there are two types. It can be maximum or minimums, and then also your extrema can be absolute or relative. It says let f be a function defined on an open, just on an interval I that contains the number c. So both of these are two different graphs. F of c, or the function of c, is an absolute maximum if that value is the highest out of all the other values of that function. Conversely, it's absolute minimum if it is the lowest value in comparison to the rest of the function. So looking at maxes and mins. Now, there's a very special relationship between derivatives and the relative extrema. Basically, what we found was when the derivative is zero or when the derivative does not exist, then that's a dead giveaway that it is a relative extrema. Now, I haven't taught you how to determine if it's a max or a min yet, but you can rest assured that it is a relative extrema when either the derivative is zero or the derivative does not exist. Now, for the most part, guys, you have to be on the lookout for absolute value functions whenever the derivative does not exist. The reason is because, remember, in order for the derivative to exist, the derivative on the left-hand side has to equal the derivative on the right-hand side. So see, at this point, notice that on the left-hand side, the derivative, or the rate of change, or the slope of this line is negative because it's going down. The slope of this line on the right-hand side is going up. So you notice the derivative on the left is negative, the derivative on the right is positive. Those derivatives do not match up at that point, so therefore the derivative does not exist at this point. All right, so that's what you have to look at. Now, the definition of critical numbers. Again, let's say that you have a function, and let's say when you take the derivative, either the derivative is zero or the derivative does not exist. Then that number is called a critical number. If you not only find the x value but also find the y value, then that's called the critical point. So the critical number is the x value, the critical point is the x and y value. And so again, to find the critical number, you take the derivative, and wherever the derivative is zero or where the derivative does not exist, then that is a critical number. Now, what you're going to learn tomorrow, guys, is that not every critical number is an extrema. Let me make sure I said that right. Not every critical number is an extrema. However, the converse of that's true. Every extrema is a critical number. Okay, but I'll cover that again tomorrow. All right.